Let's move on to object composition. It sounds confusing. I promise it isn't. So imagine you have a subscription class. Now, think about it. What sort of behavior might a subscription have? Well, you can create one. You can certainly cancel it. You could invoice a subscription. You could swap it out for a new plan. Maybe you are on the monthly subscription, but now you want the yearly. Maybe we allow for that. So all of these are examples of behavior that a subscription might have. But now it gets a little tricky here. Think about it. For any of these methods, how about cancel? Well, to cancel a subscription likely is more involved than simply updating a Boolean in the user's database table, right? Maybe you need to fire off an API request to a billing provider like Braintree or Stripe. We need a way to tell them, hey, this user has canceled, so you need to cancel your automatic billing. Make sense? So yeah, we need some way to fire off an API request here. Okay, so we need that functionality. And if we're using something like Stripe, we need to do a number of things like find the Stripe customer, maybe find Stripe subscription by the customer. And these are the sorts of methods you will often create. Okay, so we need this extra functionality. How can we grab it? Well, there are 3 different ways to add this behavior, and I'll show you each. One would be, like any other method, add it right to the class. And you've learned a little bit about visibility, so now maybe you know, okay, well, at the very least, we'll make it protected. And we need some way to track down a Stripe customer. And then maybe another one to find Stripe subscription by customer and things like that. You get the idea. Okay, so this is option 1 for adding this new behavior to the class. However, if we look over it, does it make sense? Think about it. We have a subscription class here, and all of these are clear. You can create it, you can cancel it, you can invoice it, you can swap it. All makes sense. But then these 2 here, those are methods necessary to do its job, but they aren't really related to a subscription. They're related to a billing provider, and a specific billing provider at that. So something feels a little bit off here. Not to mention, it's very likely that in other parts of your system, you'll need to track down a Stripe customer. Those are things to consider. Okay, so let's move on to option 2 for adding this behavior. We could reach for inheritance. If we have a subscription, maybe we have a new one, like a billable subscription, and we'll extend it. Now we'll take these 2 methods, and those will be exclusive to this class. Okay, so now we mostly have the same thing, but we're instead reaching for inheritance. Our subscription class, the parent, is fairly clean, and then anything related to billing is within the subclass. All right, so that works, but we're still in the same boat where these methods aren't really related to a subscription. They're related to almost like the gateway to a billing provider, yet they're contained here. So we haven't solved that. And of course, we still have methods like this that might be used elsewhere in our system, and we don't want to duplicate ourselves. So option 1 was add the methods directly to your class. Option 2 was reach for inheritance. Option 3, which is the subject of this lesson, is to reach for composability. So object composition, again, it sounds confusing. You know what it means? It just means combining types to build up a more complex object. Let's take it a step further. How simple can we make this? Object composition is when one class has a pointer to another class where behavior is located and deferred to, and that's it. And when I say a pointer, I'm referring to some property on the object. All right, so let's try it out. We've decided inheritance isn't quite right here, so I'm going to remove it. This will now be something else, and these protected methods will become public members of a new class. Okay, so what should this be called? Have a look here. What is it? What does it do? Well, it interacts with Stripe. It's sort of like a gateway to Stripe. Maybe we could call it Stripe Gateway. That's a good first step. So now we can compose this subscription class using our gateway. And typically that's done through constructor injection, like this. I'll add a constructor here. I'm going to hard code Stripe just a little bit longer, but stick with me. We'll call it gateway, and then I will initialize it. Okay. So now, if you think about it, subscription is literally composed of a Stripe gateway type. So what we were talking about earlier, this right here is your pointer to another class, this guy right here, which has behavior that we defer to. This is object composition. So now in situations like this, where we say find the Stripe customer, you would just go through your gateway. This gateway, and here's the public API of that class. Find your customer and do something with it. Now, that in a nutshell is object composition, but let's finish up with a quick heads up. You'll notice that subscription is composed with a specific billing provider. Now, depending on the size of your application, this may be no problem at all. For example, it's very likely Stripe is the only billing provider you'll ever use for the lifetime of the project. However, the tough thing is you just never know. And further, on a more technical level, doesn't it seem a little strange that our generic subscription knows specifics about our billing provider? You know, in some ways the arrows are pointed in the wrong direction. Subscription doesn't care about that. It just wants something like a gateway or a billable interface or something like that. So why don't we change this? Now, subscription just wants some gateway to a billing provider. Now, this right here is a great illustration of depending upon abstractions, which you've surely heard or read at one point or another. Subscription doesn't care about the billing provider you use. It doesn't care if it's Stripe or Braintree or some new thing. It just wants some way to track down a billable customer. So now to allow for this abstraction, we need to create a new type. And usually that's done through an interface. Create an interface called gateway and define the contract. So I'll take these two because we know those are necessary. However, you're going to notice this feels a little weird. This represents an abstract gateway to some billing provider, and yet there's still references to Stripe. Okay, get rid of them. Now, any implementation needs a way to track down a customer as well as that customer's subscription, again, on the billables end. Okay, so now Stripe Gateway is going to conform to this contract. And as soon as I do this, you'll notice PHP Storm is squawking. It's saying, hey, you need to update your methods. All right, fair enough. So we'll get rid of those. And there we go. So now, wherever you initialize your subscription class, just make sure you compose it with the proper gateway. Something like this. New subscription, new Stripe Gateway. Something like that. So now for any of these methods, again, exact same process. You'd say this gateway, find customer. And now this is entirely abstract. Could be Stripe, could be Braintree. We don't care. Let's say down the line, Braintree ends up offering better rates. Okay, we're going to switch over. Let's add a new one here. Braintree Gateway. And we add the necessary logic here. Now, wherever you instantiate this, often this might be done in a service provider or as high up the chain as possible. You would simply swap it out with your Braintree implementation. And because both of these conform to this abstraction or to this contract, everything is still going to work perfectly. You won't have to update any of this code. All right, so now you should fully understand object composition.